Hello everyone, welcome back. So today we're going to learn a new topic called electrochemistry. Electrochemistry is a combination of two words if you realize, electric and chemistry. So as you can see here in this picture, it shows you an electrochemical cell. That means how the setup is being done so that we can actually produce something out of the cell. So there are two main types of electrochemical cell that you'll be learning in this syllabus. The first type is called the galvanic cell. Another one is called an electrolytic cell. You must be also aware that in both types of cells, there will be this one type of reaction taking place, and the reaction is called the redox reaction. The redox reaction stands for reduction and oxidation. So the reason why these two words could be combined to become one word is because these two reactions must happen simultaneously, meaning these two reactions must happen together. Well, the fact that they happen together means it must be related in some way, yeah? And the thing that connects them together is actually electrons. So, reduction reaction refers to a reaction where electrons are gained, whereas oxidation is the total opposite, meaning certain molecules in the reaction would lose electrons, which will then be transferred over to the reduction reaction. Here I'm actually showing you an example of how both reactions could actually happen together. So in reduction, we have iodine, which accepts electrons, and then they become iodide ions. At the same time, oxidation happens. This is where you have a magnesium atom which loses 2 electrons, subsequently becoming magnesium ion, Mg2+. So then these 2 electrons will then move over to be accepted by iodine. Now, I would like to introduce two terms to you here. But because magnesium is said to reduce iodine, so we could actually call magnesium as the reducing agent. Now, magnesium itself will be oxidized, but it also reduces iodine at the same time. Therefore, we call them as a reducing agent. Well, at the same time, iodine itself will be reduced, and you can also say that iodine oxidizes magnesium. So that's why iodine is also what we call it as the oxidizing agent. Just remember that, when an element is being reduced, we will call it as the oxidizing agent. When the element is being oxidized, we will call it as the reducing agent. Now that you understand what is reduction and oxidation, I think some of you now might have another question to ask. That is, given the reaction, how would you be able to actually differentiate and to determine if that particular substance has been reduced or oxidized? Simple. Just look at one thing. That is the oxidation number of that particular element. For oxidation number, you just imagine it as the charges. For example, you have got magnesium converting to Mg2+. Okay, so I told you to look at its charges, right? Therefore, oxidation number for magnesium atom is 0 because it has no charges. And you are moving from a state of 0 to 2+. You should know by now that electrons are negatively charged. So if there was a gain in electron, there will surely be a drop in the oxidation number. A drop in the oxidation number, for example, in this case, when you have iodine to iodide ion, the oxidation number moves from 0 to -1. So this is a drop of oxidation number. So this shows you that iodine has been reduced. because there was the negative charge here. Back to our magnesium example, because it was moving from 0 to 2 plus, we can conclude saying that magnesium has been oxidized because they lose electrons. And remember, magnesium is oxidized and it is actually known as the reducing agent because they reduce its opposite party. More exercise for you now. Looking at this equation, I would like you to now determine if chromium has been oxidized or reduced. I'm giving you about 30 seconds. So try the ready. I think some of you here might have another question before you could answer my question. That is, how do you know what is the oxidation number of chromium in this particular example, since it looks so complicated? So I'm going to teach you how you actually determine the oxidation number here. Okay, so what happens is the overall charge of this entire molecule is 2 minus. And 2 minus is here. You have 2 chromium, 2x, because we would like to determine the oxidation number of chromium, so we name it as x, 2x. Well, there are 7 oxygens, and you should know that oxygen always has a -2 charge. So 7 multiplied by -2 gives you -14. That's why 2x minus 14 equals to -2. Solve the equation. 2x equals to 12 and x is actually 6. So the oxidation number of chromium here is 6 plus. Well, it's moving from 6 plus to 3 plus. 6 plus to 3 plus, it has gone down the oxidation number. Therefore, you can conclude that chromium is being reduced in this particular case. One more question for you. I would like you to find out the oxidation number of sulfur in sulfur dioxide and in sulfate ion. Can we all try sulfur dioxide first? Assuming that the oxidation number of sulfur in sulfur dioxide is X. Got it? It's actually quite easy. Basically, SO2 has no overall charges, so we will name it, the overall charges is actually 0. So we put a 0 here. X plus 2 times -2, because there are 2 oxygen here. And I just told you, oxygen is, the charge is a 2 minus. So my x minus 4 equals to 0, therefore x is 4. So oxidation number of sulfur in sulfur dioxide is actually 4 plus. Let's try sulfate ion now. Got it? I hope you got the answer right. The oxidation number of sulfur in sulfate ion is actually 6 plus. So if you were converting sulfate ion to sulfur dioxide, you can know that this is a reduction reaction. But if you were moving from sulfur dioxide to sulfate ion, this is an oxidation reaction. Here I just wanted to show you some of the basic expectations from SACE on you. That is, number 1, you should know that for oxygen, its oxidation number is always -2, except in one particular molecule, which is hydrogen peroxide. In hydrogen peroxide, the oxidation number of oxygen is actually -1 only. And the second thing is hydrogen. You are expected to know that oxidation number of hydrogen is always +1, except in the example of sodium hydride, where the oxidation number of hydrogen is -1. Now, with the basics of redox reactions, I believe you can now move on to learn more about the two different types of electrochemical cells. Thank you.